So with the first one, that's really 100 times the harmonic series, sum from 1 over n. So you could either use the integral test or the p-series test. Either way, it diverges. Second one, mostly I think of this as a geometric series, and I'd use that or the integral test or the Rouche test, the ratio test. This one, not so much. Most people aren't going to integrate that, although you could use that. Let's move over to the back side of this. The back side of this. Now, I habitually say, like, look at this and think about this without the constant term. I mean, this, when n is very large, this is approximately the sum n equals 1 to infinity of n over 2n squared. And guess what? This now simplifies. It's a sum from n equals 1 to infinity of 1 over 2n. And for that, this is something times a harmonic series. 1 over 2, 1 over n. What does this series do? You already said it's harmonic series, but let's see if anyone else is catching it. What does this series do? Converge or diverge? This one right here. You can ignore the 1/2. You just got to look at this. Ooh, that's a 1 there. That's a p-series. It's your harmonic series. It diverges, always. So what I would do with this is I'd use the limit comparison test. Use this series, which we know diverges, and use the limit comparison test. So LCT. This one, again, the constants, we can kind of get rid of those. 10/3, put that out in front. N equals 1 to infinity. 1 over square root of n squared is just n. We're back to a p-series test. P equals 1. This one, again, ignore this finite number. This is approximately the same as n equals 1 to infinity of 2 to the n over 4 to the n. 2/4 to the n, or 1/2 to the n. But what do we know about a series like that? It's a geometric series. Does it converge or diverge? Hello? Well, the ratio here is less than 1, so it converges. All right? But that doesn't prove anything until you put it into the limit comparison test with this. And you should be able to find that based on the limit comparison test, that one converges. This one is just a fancy u substitution. If you let u equal ln of x, du is going to be 1 over x dx. In the integral test, 1 over x ln of x dx, 1 to infinity, you'll find that diverges. You'll end up with the limit of the natural log of x. As x goes to infinity, it's going to diverge. This one, I know it's an alternating term. You've got this 3n, n, 2 to the n. Mostly what I see is this 3 to the n over n, 2 to the n. And that term, call it a sub n, the limit as n goes to infinity of a sub n is going to be infinity. So what's that telling you about this? Diverges. So basically the nth term test says that one diverges. Done.
We checked it. It looks like a telescoping series.
It's not. It's an alternating series, and yeah. Yeah. Let's see. This one. Oh. This one's a good one. In fact, Muhammad, you were keen on this test earlier. Which test would you use for this one? Root test. And that one's going to converge. How about this one? Ratio test. Factorials are great for the ratio test. And in fact, if you wanted to, n and n factorial, this can cancel into this. You could rewrite this as sum from n equals 1 to infinity of n minus 1 factorial over 3 to the n. Basically, I canceled out that n. But yeah, the ratio test. And it's going to converge. ln of n over n to the nth power. Wow, a lot of n's on that one. Well, you got something to the nth power. That's kind of hinting you at Muhammad's favorite test, which is the root test. And using the root test, you can see that the limit of this, ln of n over n, is going to go to 0. And you might have to use L'Hopital's rule to convince yourself of that, but it's okay. You can do that. You're professionals. You have my opinion, or my permission. Another root test problem here. And this one's going to go to 0. Let me give you a bonus one here on this, because I asked this sometimes as well. 1 over n squared minus 1 over n to the 4th. And a lot of people want to say, oh, that's a telescoping series. It's not. If you actually expanded it and looked at it, it's not a telescoping series. You don't get... Yeah, you figured you wouldn't, Siri. How timely. But what you can do is you can split it up like this. Sum from n equals 1 to infinity of 1 over n squared minus the sum from n equals 1 to infinity of 1 over n to the 4th. And now what would you do here? P-series. This is a P-series and that's a P-series. Use the P-series twice. Both of them have to converge in order for the series to converge. Now, if you want an example of a telescoping series, that'd be something like the sum from n equals 1 to infinity of 6 over n times n plus 3. And then you have to split that up using partial fractions. So that's where you'd end up. Now, I can't remember, but I think this one splits up like this. 2 over n minus 2 over n plus 3. And that's a telescoping series. You can actually calculate the partial sum and take the limit as n goes to infinity and actually calculate the exact sum on that one. But that would be a telescoping series. You could probably prove the convergence of this in other ways as well. You could use the limit comparison test. That would work. You could do the integral test. That would work. But mostly, I'd probably recognize this as a telescoping series. So, all right. I hope that gives you a good idea of all the different tests that you have and some of the thinking that goes behind choosing which test to use. So keep in mind that you'll actually have to do a few problems, from scratch. You can look at last year's exam to try and get an idea of some of those things. Let's see. So here's some of that stuff. Let's see.
So is this going to
You
be
got
the last part of the exam and you time us?
No, I don't time you on the 2-minute drill at all.
Oh.
Yeah, I just call it the 2-minute drill because it's football season. Right? That's when I first came up with this problem. It was during football season, and of course, you always go through the 2-minute drill in football season. But no, I am not going to sit there and go, ready, go, and hit the stopwatch. No, you can take 2 minutes. You can take 20 minutes. I don't care. You're still going to have, roughly 2 hours to work on the exam either way. So if you want to spend it all or very little on that part, we're good. Now keep in mind that this test does have some stuff outside of Chapter 11. It starts at section 10.3. So that's going back to all that wonderful stuff that you guys really loved in polar coordinates. So don't skip out on some of that stuff. But that's all I got for today. Any 10.3? I think that's the last. Is it 10, all right, or it'll be 10.4 then. All right. So I'll have to take a look here. But I'm going to stop things here. Yeah, it's going to be some stuff on polar coordinates. So good luck with that.